All right, 2.1.2. This is going to be a relatively quick lesson as well. Y'all are pretty good at this. Y'all have already been doing something. This first one, 2.1.1 and 2.1.2, are really just a continuation of the things we were doing in Unit 1. Okay, really focusing on solving equations. The key thing I need to point out to you, and this may be for some more than others, you really have to remember those properties and order of operations and how to solve. So read through this introduction, read through these key concepts, pause the video, write them down if you need to, or go back to your notes and read the notes because all this same stuff is in those notes. All right. Solving equations, these are the steps you want to look at. Okay. Some key pieces of information talking about no solutions and things like that. We'll get into that to a little more detail later as we cross that. One solution is when you have x equals a number. If you get a phrase like this where x equals x or 0 equals 0, that's infinitely many solutions. It means it's the exact same thing on both sides. We're going to do a lot more detail with that as we go. But let's look at some examples here. So example 1, solve this equation. Step 1, get your variables on the same side. Okay, that's the first goal that we have. So right now I have 5x on this side and I have 2x on the other side. Think about that equation as being the separation between your left side and right side. Okay, that equal sign. So I need to move the 2x or I can move the 5x. Now, in my mind, I always want to move things in a way that is going to keep it as positive as possible. I want to avoid negatives wherever I can. So it makes more sense to subtract the 2x on this side, and I'm subtracting because it's a whole term. Remember, terms are anything separated by addition or subtraction. This whole term needs to move, and that's positive. It's a positive term, so we're going to subtract it. We're going to undo a subtraction. Okay, so that again, that'd be the subtraction property of equality. Now, once I do that, let's rewrite what's left. So I have 3x plus 9 equals, and then that minus in front of that 36 comes with it. It did not go away. So now I have my variables all on the same side. Great. Now I want to get any terms that don't contain the variable x to the other side. So in this case, I want to move this 9. Again, it's a positive 9. It's added, so we want to subtract 9. I'm hoping that this will be a relatively easy lesson for most people because as long as you understand order of operations, it's not that bad. Okay, or it shouldn't be that bad. All right, so negative 36 minus 9 is going to be negative 45. And then the last thing that I need to do is divide by 3, right? Because that's multiplication. It's multiplication, that's 3 times x. And to undo multiplication, we would need to do division. Okay? So what you're left with is x equals negative 15. Now, you should always plug it back in to check and see if it works. So we have 5 times negative 15 plus 9 equals 2 times negative 15 minus 36. Okay? And when you type those in, 5 times negative 15 is negative 75 plus 9. And that's going to be negative 30, not 33. Minus 36, and then you should see if you get the same answer. So negative 75 plus 9 is negative 66. And negative 30 minus that, minus 36, is negative 66. So I do indeed get the same answer. It does check out. That means that 15, negative 15, is my solution to that equation. Okay? Moving on. Solve this equation. All right. Again, we start by trying to get our variables on the same side. Okay, we want to get those like terms together. But again, I also need to keep in mind that it's separate, right? Left side, right side. So, as I said last time, there's a couple of ways you can go about doing this. One, you can move the 7x, right? So that you can go ahead and have that on the other side. Or you can add 9x to get everything positive. Completely up to you. This is a rare scenario where I might suggest go ahead and moving the 7x, even though that's going to make you have a negative coefficient. The reason why is because you will already have your constant, the 4, and the term with the x separate if you do that. If you don't do that, if you add 9 to both sides, then you're going to have to then subtract 4 from the other side, and you're going to put a negative anyway. Completely up to you how you approach it. I'm going to do the minus 7x just because I can, just because it's good practice to be able to do it both ways. 7x minus 7x goes away just like last time. Okay, I want to get rid of that variable on one side. On the other side, I have negative 9 minus 7, which is negative 16x. Remember, when you're combining like terms, you simply add the coefficients. Negative 9 plus negative 7 is the same thing as negative 9 minus 7, which is negative 16. Lastly, this is negative 16 times x. So we want to use the division property of equality to undo that multiplication. And I want to divide by negative 16. Okay? Now, it would be fine to leave it like that, except for the fact that it's not fully simplified. Okay? So 4 and 16, that reduces to negative 1, 4. Simply reduce that there, simply simplified. And then the last thing that you probably want to do is use the reflexive property to say x is equal to negative 1, 4. And then what do I need to do after that? I simply need to check my answers. So 7 times negative 1, 4 plus 4 should equal negative 9 times negative 1, 4. All right? So 7 times negative 1, 4 is negative 1.75. Okay, and I'm using the calculator to do this. That's why I switched to a decimal. You're welcome to leave it as a fraction if that makes you feel better. And then negative 9 times negative 1, 4 is positive 2.25. Okay, again, leave that as a fraction if it makes you feel better. So then to clean this up, do negative 1.75 plus 4, and you get 2.25. So basically, I'm simplifying the left and right side to make sure that they do indeed give me the same answer, in which they do. Okay, so that checks out, making this your solution. All right, I'm going to stop this video right there, and then we'll move on to example 3, 4, and 5 in the next one.